Hey y'all, it's me, Miss B. Today we're going to be talking about the transformations of functions. So here, these questions right here are the questions that I asked you in your skill checks. So just check those answers. Pause if you need to. Okay, so vertical stretch and compression is where we're going to start today. So with a vertical stretch or compression, the value that's going to change is y. And what that means is you're going to multiply the y value by a. If a is greater than 1, then the graph is going to stretch by a factor of a. So it's getting skinnier but taller. And if 0 is, if a is between 0 and 1, it's a fraction, then the graph is going to compress. And so it's going to get shorter and fatter by a factor of a. I wish I hadn't wrote these here. Oopsie daisies. Gonna erase these and write them again. Okay, so first we have our graph. And I already went through the liberty of graphing it for you. I already went through labeling it for you. So now all we have to do is transform. Now, if you remember, what we're doing is we're multiplying the y value by a. So what we're going to do is this is going to be x and 3y. Again, that 3 is outside the parentheses, so it's going to change y. Inside the parentheses would change x. So x, we are going to keep the same. So 0, 2, and negative 2 are the same. And our y values are going to be multiplied by 3. So 0 times 3 is 0, 2 times 3 is 6, and 2 times 3 is 6. So we graph those points. 0, 0, 2, 6, and negative 2, 6. If we graph this, it's going to look like that. And as you can see, if we were to hold that bottom point and stretch it, it's going to get skinnier. Now for this next one, we're graphing and labeling 1/2 x. 1/2 f of x. So again, our y value is changing and our x value is staying the same. So I hate those fat arrows, they're so ugly. There we go. So here is x, and we are multiplying y by 1/2. X stays the same. Y we multiply by 1/2. So negative 3 becomes negative 1.5. 2 becomes 1. Negative 3 becomes negative 1.5. And 2 becomes 1. Then we graph those points. So go ahead and do that. And so as you can see, we have our graph, and it looks like we took those peaks and just smushed them down. All right. Now, we aren't going to really focus on horizontal compressions. They just really aren't worth going over. They're really interesting, but just nothing we need to cover in this class. So we are going to focus on multiple transformations for a parent function. So here's the order of transformations. We got horizontal and vertical translation. 2 is vertical stretch or compression, and then reflection as our last one. So you need to think about what should come first. Now, I'll tell you, vertical stretch or compression is going to come first. We're going to stretch it, then we're going to reflect it, and then we're going to do our translation. So that is the order. Make sure you write that down. It's not in order. That is just to kind of get them all out there, and then you have to kind of think about it. So think through, why would each of those go in that order? Here are the steps we're going to follow. First, we're going to ask ourselves what term is changing and how. Then we're going to pick our points that we're going to transform, just like we did in last problems. Then we're going to do our first transformation, then our second transformation, and then we're going to graph the new thing. This point right here actually is terrible, goes off, so let's pick a different one. Let's do maybe 1, 1 instead of 4, 4. Nearly had it. 1, 1 instead of 4, 4. Okay, and so let's do our transformation. So let's focus on what comes first. So do we have any vertical stretches or compressions? The answer is yes, that 3 right there. And so that's going to be multiply y by 3. X stays the same. Multiply y by 3. 2 times 3 is 6. 0 times 3 is 0. And 1 times 3 is 3. Next up, we've got plus 2. Now that's outside the parentheses, so that's going to be up 2. So we're going to add 2 to y. Green's kind of hard to see. We'll keep it. So x is staying the same again. And y, we're going to do 3y plus 2. So we're adding that 2. 6 plus 2 is 8. 0 plus 2 is 0, 2. And 3 plus 2 is 5. Now we want to graph those points. So negative 2, 8. 0, 2. And 1, 5. So if you look at that, you can tell that the graph has been stretched and shifted up 2. All right, this next one here, we've got, let's do a different color. I didn't like that one. Some new colors here. So here I've got x minus 1 in the parentheses, so that's going to make us move to the right. So we're going to add 1 to x. I know it's the opposite of what we think because it's inside those parentheses. So we're going to do x plus 1, and y does not change. So this becomes negative 1 and 3. Y stays the same. Next, we're going to add 2, so that means we're going to add 2 to y. So we've got our x plus 1, and we've got our y plus 2. So we've got 3 plus 2 is 5, and 5 plus 2 is 7. So graph those 2 points. Negative 1, 3. That's not right. Negative 1, 5. There we go. And 3, 7. And then that's not 7, that's 6. This is 7. I feel like this doesn't look right to me. Whatever, that's fine, right? Negative 1, 5. Why does it look so weird? Oh, because that's not 3, that's, okay, 3, 7. There we go. Figured it out. Alright, so there's our line. It looks like it just shifted up, but if you look at the individual points, you can tell that they shifted up and to the right. Alright, and then we're going to skip this last one here. It's not a very good graph, so that is it for today's video.